So Delta also has some additional optimization that it can do on top of just Parquet files. Now let's look at our big table here. We know that it's going to store, data like this because this is Parquet. So this is the first optimization just by using Parquet files. It goes from this big bit of information with lots of letters to a nice narrow bit of data with lots of less letters and lots less memory to use. So on top of that, let's look at this table. Now if we save this to Delta, we might split it out into different row groups such as this and save these into files. So because it saves as Parquet, these are our 3 files that it uses. Now what it does is if we query this and say we want to select all the sales with a sales number, these are the numbers, right? The first column is the names, and then we have the sales, which are the numbers. We want to know whether sales is greater than 14. Now of course Parquet has this transaction log. So every time we add a file, not only does it say I'm adding file A, B, C or whatever, but it also goes through and it does some analysis on the columns and it writes down some data about the file you're adding. In this case it's writing the min and max, and it writes the min and max of a lot of the columns in your file. So this, for example, the first one is going to say the min number is 9 and the max number is 12 in the sales column. The second will be 15 to 20. We can see this, right? The min and max of all the values in that column for that file. Now we say, I want to select where sales is greater than 14. An optimization it does is, well, I can see that I know the first file has sales between 9 and 12. So if I'm just trying to load all the data with the sales is greater than 14, I don't need to look at this file. Now if you imagine you have lots of files and really big data, skipping the files and skipping all the data you need to look in to find the answer, going to save a lot of time. So without having to open that and read the data, it can already know some of the information about the data in it. So this makes it really, really quick. Now you might ask, of course, well, what about the name column? So again, you can do this, right? Letters have a min and max. We have an alphabet, it's ordered. So I can see when the name starts with D. Let me see the name where it starts with D. So I can look, and D actually will only fall in this last file. And I'll look, it's not actually in that, but I know D is within between A and S. So I'm still going to look in that one and say, okay, there aren't any names beginning with D. But I only have to look in that one file because I know not to look in the others. So let's say another way, right? Imagine we have the same data, but how we've added, it's come out like this, right? By the time we've added data. Because a lot of these are, when we add the data, it writes to this Parquet. And we can see here, we're going to say, let's select the sales where the sales are equal to 14. But in this specific version, we can see actually 14 falls within every single one of these files, right? 14 is between 9 and 15, 8 and 16, and so on. Just going to have to look at everything. So is there a way to make this better? Well, yes, there's some commands that we can do. And this is called zorder and optimize. So what we do is we run this command called zorder on the sales column. And now it's going to order it by the sales column. And it might internally optimize things and save things. So in this case, it's saved things in 3 different files like this. And what it's done though is we can see we've ordered on the sales column. And this is going to make it a lot easier, right, if we're looking at where sales equals 14. Because the first file has sales between 7 and 9. The second one has sales between 14 and 16. And the last one has 28 to 35. Because we've ordered by this column, this means it's going to be much more efficient and more likely to skip files. So this is called zorder and optimize.